This video is about the question that you have as an extended writing task in the Particles homework booklet. I'm going to talk through my thinking as I read this question and show you the way that I plan to write a 6-mark answer. So, I'm told a diver is swimming underwater and she's breathing out bubbles of gas. The bubbles of gas are rising to the surface. Right, I'm going to pause at that point and just have a think about what's happening. So I'm in an ocean. A bubble is produced down here at the bottom of the ocean. And I think the key thing that I'm going to start with in my answer is the idea of pressure increasing with depth, which means down here at the bottom, the pressure is high. But as I go higher, the pressure is going to get less. The temperature of the gas does not change. Now that is a really important sentence. If the temperature is fixed, that means the kinetic energy that is stored in the particles of this gas is also fixed. That kinetic energy stored at the particles is not changing. Therefore, the speed of the particles is fixed. If you think about half mv squared. If the kinetic energy store is fixed, the speed of the particles is also fixed. And those particles, this is a bubble of gas. So here is my bubble. But that bubble has got gas particles zooming about, far apart, very weak forces between them. And they're zooming apart, zooming around. They've got lots of kinetic energy, but that is a fixed amount of energy. So they're zooming around at the same speed all the time. And those particles, of course, are colliding with walls. That's what's causing this pressure. So that's the 90-degree net force on the surface from the gas particles colliding with the surface of the bubble is going to create the pressure. And that pressure inside the bubble has got to be equal to this pressure from the water outside the bubble, because otherwise the bubble wouldn't exist anymore. If the pressure outside from the water was bigger than the pressure inside the bubble, then the bubble would implode. If the bubble had a greater pressure inside of it than the water outside of it, then it would explode, but it wouldn't rise to the surface. And this bubble, we are being told, rises to the surface. So this bubble's going to go up, but the pressure inside and outside the bubble has to be the same. That has to be in equilibrium. So, the last bit of the question. Yeah, I haven't actually finished reading it yet, that's true. Explain what happens to the bubble as it rises to the surface. And we need our answer to refer to the gas equation. Well, this is Boyle's law. This is P1V1 equals P2V2, because you have got a fixed mass of gas trapped in the bubble. And we've been told it's at a fixed temperature. So it's definitely Boyle's law. That's the equation they want. The kinetic theory, well, I've started going to that. That's our idea of the particles here in the gas moving about very quickly and being far apart from each other. And then we have to link in those ideas of the particles and these collisions. It's really important. We talk about what's causing the pressure here. The collisions, the rate at which those collisions happen. So at high pressure here, we have got a high rate of collisions. And a lower collision rate up here. Because that's what we know about pressure. So all we've got to do now is link that to what's actually going to happen to the bubble and to its volume. So if we think about our equation down here, if the pressure was really high at the bottom, and I'm just going to use a value of 10 to give it a number, and that little bubble was produced, we know at the end P2V2 has got to also equal 10. Therefore, if the pressure has gone down so much it's gone all the way down to 1, the volume will have to then have gone up to 10. So what's happening is, as the pressure decreases, the volume is increasing. So as the bubble goes up to the surface, its volume is going to increase. So volume high, volume low. And that's where I think I've got myself ready to go and write my answer. I hope you have a successful time in writing yours too.